lived too many years in the north, and it's always cold there. And when you move south, like now, and allergies kick in. So I have a terrible cough, but I'll hopefully deal with it right now. Okay, so RDC performance monitoring. Can we go? Next slide. Yeah. So I've been working with 15 minutes. I can do Pecha Kucha style. 5 seconds on each slide. So I've been working with the real-time communication for the last 10 years, contributing to standards, both IETF and W3C. Most recently with the Stats API in WebRTC. If you look at the standard, if you implement it, you'll see my name there. That's like my claim to fame right now, but that's about it. I have a PhD in congestion control for multimedia. So why is performance monitoring so important? Because everyone talks about it, and it's something that most people think about only when they deploy. When it's in a lab or when people are working with WebRTC, they're quite happy because they open 2 tabs and everything works. And when they deploy, then they feel all the pain. So pretty much the biggest deal with real-time communication is latency, right? That's where it differs from streaming or YouTube or Netflix and most of these things. So this is a slide that I just took off. So this is from MVC. Today we were doing a demo, and we always talk about like, do networks burp? Do we have buffer bloat and all these things? And this is a call between here and Helsinki. I was talking to the team, and you can see like we have spikes of 500 milliseconds off and on, but then there's this big burp, which is when I said, okay, let's close the call because I think it's not working out. And you can see the call like it jumps to 3 seconds of latency. So this is quite common. And if you deploy it, it's likely that many of your customers also feel the pain. So typically, what's the game plan, right? And I started Callstats.io last year, but we started working with some early customers, right, in 2012, 13, when they came and said, Varun, can you help us with this? And I said, okay, what's wrong? They said, like, we're using this platform, and we're doing a health app, and some of our customers complain. So we had to go down there and debug it. So the first thing was do nothing, right? Because we had to debug it, and it was deployed, and only 20 users were using it, but all 20 unsatisfied customers. So no VCs was willing to fund them because you can't even get 20 people to use your health app. So their problem was that this is someone else's problem. So they were really telling us that we don't care about this. We just wanted WebRTC, and it should solve this problem. It's not our problem, right? And you're like, okay, let's do something. But so we came up with this kind of, so if someone called them up, this is the thing they would use. So they would either say it's insufficient capacity, or they would say, oh, misbehaving browser, you're just using the wrong one. What if you use Chrome or something like that? Or it's NAT traversal. Actually, it was NAT traversal in the end because there was one ISP in Finland on the mobile networks was blocking UDP, and they didn't have turn, so they're like, what is turn? I don't know what that is. Right? What is turn either? So we said, oh, okay, if this doesn't work, then you just say it's the other customer. So someone's complaining, you say, no, the person you're calling, that guy has a problem. It's not your ISP, but the other guy's ISP. So this is like a joke, but we actually used it. And it worked because some of the customers stopped complaining. They said, okay, whenever it works, tell us. So do nothing, and waiting for feedback from your customer is perhaps not the correct way to go with it. Especially since we are in the web world and people use Google Analytics and Mixpanel and what have you, and we are always ahead of the curve, right? You're already looking at your page load times, you're looking at where your customers are coming in, what flow are they going through, and you have all these different ways, show them a blue box, green block. So why can't we do that for WebRTC, right? So there are ways we can do it, and there are ways that people have been doing it for a long time. So there is RTCP monitoring. It's been there since the beginning, as in we had RTP and then we had RTCP. Like they came together, and then some years down the line, you have RFC 3611, which is our XR, extended reporting, which lets you report things which are not in the standard RDCP, SR or RR, or sender reports and receiver reports. And then there's the WebRTC Stats API, which came straight out of the fact that you have these things which are being measured by the RTC stacks, either in the browser or in native apps, and these need to be exposed to the application in some way. And then you can use the data channels to send it across, or you can send it to the cloud where you can aggregate the data, compress it, and analyze it, use a Hadoop cluster or something similar. So we are already there. Like a lot of the things that we need today for doing this already exists, so why not use it? Right, so So a lot of people, as in even today, people say like, one of the ways that we do debug today is, we use WebRTC internals. So Mozilla has it, Firefox has it, and Chrome has it. And what they do is they get this bunch of stats. They ask their customers to do that. Then they say, oh, export, send us via email. I'll analyze it, and then I'll fix it if I find what is it. And then I'm not sure if I should deploy this specifically for this user, or does it affect several users. And how do you know if after you deploy it, the same customers actually struggling with the same problems again or not? So you need to create this kind of repeatable model where you're able to collect and fix things on demand without waiting for either customers' feedback or even being able to, or even to actively monitor calls. So this is RDCP monitoring. It's been there for perhaps maybe 12, 15 years. People can correct me, even longer. So what does it do? So you have some things like you have an endpoint, you have 2 endpoints, middle box, several endpoints, all implement RDCP and extension reports. The extension reports can be sent to a third-party monitor, or they can be sent to an O&M solution, which is pretty much what a lot of ISPs do. If they have SIP phones, they have RDCP extended reports implemented in the SIP phones, and then they collect them in wherever inside their infrastructure. So this is already possible, and there's also a couple of RFCs there. We've been working on a new draft which basically discusses inside the WebRTC context what extended reports would be interesting for the endpoints and also for middle boxes to consider. WebRTC Stats API, quickly, it does the whole pipeline. So you have the transport statistics, you have the audio-video statistics, you have the data channel statistics, and pre-buffering, post-buffering, how many frames were decoded, how many frames were dropped, if there were discards, if there's a playout delay. So if you're a geek with who loves the pipeline, the multimedia pipeline, and wants to see where the problems exist within an endpoint, you can just query the pc.get stats for each peer connection, and you'll get a bunch of stats for that. And with the new, because of the ORTC effort and version 1.1, as they call it, the WebRTC has been inheriting some features from there. And RTP sender and RTP receiver are things that came out of that. And I think last October, when the last TPAC meeting was, we discussed this, and we agreed that this is going to be in version 1.0. And I think there is already a pull request, or which got merged recently this week into the main branch. So we're going to see this deployed either in Chrome or hopefully in Chrome and Firefox within the next few months. So you could query pc.getStats, and then you can reconfigure using your RTP sender and receiver. And we've seen some of these ideas already presented before. So I think there was the TalkBox presentation, and there were some others where they were controlling frame rates and bit rates, and hence so on and so forth. So these are things that you could do at longer timescales and let the congestion control work at shorter timescales. So when we do performance monitoring, there are a level of things that you need to look at. So from a business perspective, and there are some things from a quality perspective. And then there is the geek stuff like media quality. And so the first thing is annoyances, because that's the thing that pisses off your users, right? Because things like they have to repeatedly redial, or something. They call something, it breaks, then they call again, and they keep hoping for magic to happen. They press the button once, and then they were unable to establish the call, then they press the button again, hoping something's going to magically change. And maybe it did change in soft phones or things like that. But today, with WebRTC, with all the settings already pre-configured, it's impossible unless you change your turn servers or you change something in your configuration with each attempt. So some things that, from a business perspective, people care about, what are the total calls made in the hour or on the day, what is the total call duration, which leads to average call duration, so you can price your things correctly. Like the company's example that I was giving, doing healthcare, they priced it first at 15 minutes pulses, then they realized, after doing some testing, that they could price it at 10 minutes because the average calls are all 8. So they said, changing it from 15 to 10 didn't make any difference to anyone. And they could, everyone was happy suddenly, because the doctors were happy that they could do this. They could do more calls in in 1 hour. So as I showed before, so then there's transport metrics. As I say, you can see here again, there's a pulse of 5 seconds. And with quality, most people talk about how can you do quality, right? So you have all these metrics which are all raw, and you can like mix them all together to come up with an objective score. So we work with a lot of the standards there are. So there's so many ITUT standards which talk about audio quality, video quality. Very little for VBR video traffic, and we've been experimenting with some of them. But here's one example. Like there's a 3-party call mesh. You can see 2 people. So higher values mean better, lower values mean worse. And you can see that 2 people in a call have comparable quality, and the 3rd person comes in, and he struggles. Then at some point he drops off, and then he comes back up and he calls again. And this is also a bug with, it's been very well identified for Google congestion control that you can see at the end of the call when like one guy drops off, you see like this spike there. And this is like a very well-known fact of this congestion control that the early users see a lower delay, so they fight for capacity more. The 3rd person who comes later sees a higher delay and then is not able to compete, and therefore his quality drops. And this is like a bug and this can only be identified if you actually introspect your logs very well, and you'll go with a tooth comb and you say, okay, why did this happen? And this would not be possible if you don't monitor your calls for at least quality. And so connectivity is a big issue. We talked about mobile here. Mobile, this is Helsinki. There's a company which is NetRadar, which does active measurements. You can see it's like downtown area, it's all green, and you just go like 2 kilometers off, it starts to become yellow. So it's like not like high connectivity, even a place like Helsinki cannot be guaranteed, as in you will have patches of yellow somewhere or even red, which means it's even less than 200 kilobits per second. So adaptivity, so this is congestion control, right? So you have a sender, receiver, you're measuring things, you have RDP sender, SRs and RRs, you're sending media, you have quality monitoring. Then you have short-term adaptation, which is based on FEC, retransmissions, congestion control, temporal scaling, adaptive switching of video. So this is simulcasts and SVCs. But then you have long-term adaptations like codec choice. So you could change codecs because that's something that you could do if you find that things become better. You use a better codec. Then you have packetization size. This is very common with Opus. If you're doing high quality audio apps, then you change the packetization, you use shorter. Then you have flexible FEC, like interleaving, and then simulcast sets. These are things that you can change, like changing the whole simulcast set over a longer period of time. Yeah, so this is like a trace from mobility. You see like these are streams where it's unusable. Then by using congestion control, you can make it better. There's an ongoing activity in the IETF, which is called RTP, Media Congestion Avoidance Techniques, so RMCAT. And so you have the Google congestion control there. There's a proposal by Cisco. There's a proposal from Ericsson, which recently announced that they open sourced their implementation of the congestion control with Open WebRTC. It's available as of today. We have our own congestion control, which is available there. So to leave you with one slide in the end, these are things that we see today. You have congestion control, simulcast SVC, DSCP markings. This is another RFC which got published recently. It just took like 6 months, which is great for IETF because it hardly takes anything to be published in 6 months. But went from draft to RFC within one cycle. Then you have turn server, conference servers, then network management. Some people talked about NFV and deep packet inspection, SNMP, traps for like doing this. So I just leave you with the last slide. Don't do this way. Like iterate all the time, collect and deploy and fix things in a cyclical manner. And that's it. I think if you have any questions, we're also hiring. So if anyone's interested.
Questions 1, 2, 3. And we'll try and please keep them brief.
I thought I was too technical for people here.
Yeah. Any questions over 30 seconds, owe me a beer.
Okay. Where do you think is the trade-off on collecting as much statistics as possible from the client where you probably have a network problem or a low capacity network? I don't know, where do you put the point to stop collecting statistics to get a better network?
Well, if you do pc.getStats, you can see if your network's actually being, you can see if you're sending enough data. If you're not sending enough data, then you don't send all the low-level statistics. So we do the same thing, we aggregate it. So if we can do 1 second stats, we do 1 second stats. If we think that there's congestion, then we do like 20 second stats, 30 second stats, 1 minute stats. Or if things fail, then we do it at the end of the call. But you need to send something at the end. If it's really a low capacity network, if you're in like Asia, like India, then you could actually think of doing it at the end of the call. And that's quite often what people are doing. They just summarize the statistics at the end of the call, or pick parts. They say, okay, there were 5 periods of congestion, and this is what we saw. And they just report that, and everything else was good. So you can do that as well. So there are things that how you can slice and dice the data. Since the endpoints, so nothing in the endpoint, like all the stats are available there, right? So and you're using client endpoints processing power. So you can use it to do whatever. Unless it's a mobile, then be careful. Anyway, then you're not supposed to like send 1 second
Matthew.
feedback.
Hi, that was really cool. It's a really, really cool product. So congratulations.
I didn't talk about the product because I'm not supposed to talk about the product.
Technology.
There's no product.
It's cool. But a quick question, actually wearing a telco hat for once. Something that comes up a lot is the whole mean opinion score style MOS stats. Apologies if I missed this, but have you got any way of tracking between the completely algorithmic analysis and the more sort of human opinion stats, which the operators will talk about? You know, they say, what's the MOS of Opus under these bandwidth conditions? Do you have an answer to that?
Well, you could do this in the lab and you get an answer for that. But what we do, let's say one answer which is related to our product, is that we allow the web app developers to report MOS scores. So they can throw a widget, get an opinion, put it on their web server if they're collecting that information. But they can also send it to our, so we have an API which collects this information, and then we can correlate it with the other data. So it would show up in the same place.
Very cool.
Then there was a question, I think, just on there, and then finally. Was it? Okay. No, maybe not. Well, let's go to the middle there. Here. There was another question, but it seems to have disappeared.
Okay. I was just wondering, is there a benefit over getting the stats from the JavaScript and backhauling over data channels versus the media server directly looking at the RTCP packets and doing the analysis itself? Is there more richer information available via the JavaScript API?
We are getting it richer. So if you have something that you think should be, then send us an email on the mailing list. We'll add it. Like if you need something in the pc.getStats and you think that is very important, then we can add it to the API, as in it's still.
But, I mean, existing stats, is there more information than what's already in the RTCP?
Sure, because it's got the pipeline which is pre-decoding and post-decoding and rendering. So like frames discarded won't be like things that you would know unless you have a simulated jitter in your de-jitter buffer in your media server, which would then say, okay, if I have a 200 millisecond delay, then this would actually be dropped or something. But that's quite common, but that would anyway result in some packets being dropped at the media server itself because it's trying to catch up or sending a FIR request back to the client. So there are things that you can do in the middle boxes which you cannot do at the endpoints, and it depends on your topology. But in the end, all of them are XRs, so they're extended reports, which are implemented and exposed.
And thank you.